So, welcome to module 10.3. We are doing the JAG compiler backend. So, we have seen so far how to handle variables. Now, we will now see of how to handle expressions. Now, while we start looking at expressions, we need to start looking at the grammar of how expressions are evolved at in this case. The expression is basically we have a term followed by an optional operator term pair, right. So, this is how we define the first grammar, right. So, expression will have a term followed by an optional. If I put star, it can be 0 or more repetition. So, it can be just term or term op term or term op term op term, and it can go on like that, right. And what is a term? A term can be just an integer constant like 150, 200. It can be a string constant like double quote something. It can be a keyword constant. So, what are all the keyword constants? You can see it can be true, false, null, or this, right. The last thing that you see here, true, false, null, or this, right. This can be a keyword constant. It can be just an identifier, right. I, C equal to I plus j, I is a term, right. It can be an array expression, A of 10, A of 10 as you see here, right. So, A with followed by some expression here, A of 10. It can be a subroutine call, and a subroutine call will be just a subroutine name with an expression list, or it can be a subroutine name dot it can be a class name dot something or a var name dot something, right. So, just a subroutine name with expression means it belongs to the same class, otherwise this belongs to some other class, or so there can be this. And then of course, there is a subroutine call, and then it can be an expression within parenthesis, or it can be an unary operator and a term, and there are two unary operators, one is minus and another is negate, right. And what is an expression list? It will be expression comma expression multiple times, right. And there can be subroutines without any expression also, right, right. So, these are all the things. So, let us give some examples of term. 5 is a term, x is a term, x plus 5 is actually a term, right. X plus 5 is also a term, right. Right, it is term op term. X is a term, 5 is a term, plus is an operator, x plus 5 is a expression, sorry, x plus 5 is an expression. Now, if you look at subroutine call, math, math is a class name. If you look at this, math dot abs, abs is a subroutine name, absolute value. Then there is an expression list, right. This expression list here, what you see here is an expression list. So, the expression list here has only one expression, and that name is x plus 5. So, expression list has one expression and nothing more, and that is x plus 5. Now, I could have another term would be var name is ARR, and then followed by this brackets, square brackets ending with the square brackets, and within that I could have an expression. And what is that expression here? The expression can be a term, and what is a term? Term can in addition be a subroutine call, and a subroutine call in addition can be can derive to this class name dot subroutine name math dot abs of x plus 5. So, this R of this is actually a term wherein ARR is this R of this ARR is a var name followed by the square and ending by the square parenthesis, and math dot abs, and then var name, and this math dot abs of x plus 5 is an expression, because this expression has one term, and that term in turn is a subroutine call, and that subroutine call in turn is a class name dot subroutine name math dot abs followed by an expression list. The expression list is an expression which has a term followed by a op followed by a term, and that term is var name identifier x. This op is plus, as you see here, op can be anything here, op is plus, and the next term is a integer constant which is 5. Okay. Right. Now we can also have a subroutine call. Foo is a subroutine name followed by an expression list followed by this parenthesis, small parenthesis, and n parenthesis as you see here. So this is a subroutine call and followed by an expression list. The expression list has one expression followed by expression list can have an expression followed by many expressions. In this case I have only one expression. That expression essentially has one term to start with, and that term essentially is a var name followed by a parenthesis. So ARR is the var name followed by a parenthesis followed by a square bracket ending with a square bracket, and inside that there is an expression, and that new expression is a subroutine call because that new expression has a term. That term essentially has a subroutine call. That term actually has a subroutine call, and that subroutine call has a class name which is math followed by a subroutine name .abs, and again there is an expression list. That expression list has one expression, and that expression has a term which is x, and the term is an identifier var name with x, and then a op which is operand with operator with plus, and another term which is an integer constant which is 5, right. So this is the way we need to start interpreting expressions. So the grammar per se will capture all these expressions in this manner, right. So try and understand this in this perspective. Now I want to do a into b plus c, right. The infix is a into b plus c, but we will not do the prefix here. Prefixes I put the operand before. I am doing something called postfix, which we have already seen on expression evaluation when we are doing the virtual machine. So what we do here, we just put a b c plus star. So this means essentially push a, push b, push c. Then when you encounter a plus, what you do? You do b plus c. You just take the top two elements in the stack and add them and store the results. So at the end, after I see the plus, what will be on the stack would be a followed by b plus c on the top and a in the bottom. Then I have star, which will basically give you a into b plus c. So this is the stack oriented stuff that we need to do. So given an expression of any part, we need to convert it into this postfix notation, and that is going to become extremely important. So remember, when we are handling expressions, we have to handle postfix notation. So essentially, if I have x plus g of 2 into y 2 comma y comma minus z minus phi, g is a function call, x and phi are variables. So this is how we generate this parse tree. We'll have we'll just have this x plus g of 2 comma y comma z minus, so x plus g of 2 comma y comma minus z minus phi, right. So when I want to evaluate this, I put push x, then I say push 2, push y, push z, then negate z minus, then call g. So when I am calling a function, already I assume that all the arguments for that function would be already in the stack, which is anyway in the stack now, 2y z, and I say call g, and then what we say is, once call g completes, the result of this g of 2 comma y comma minus z will be on the stack. So when I say call g, at the end of this call g, I know that this 2 y z are all going to be removed, and and the result 2 y z which are 2 y minus z which are part of the top of the stack are removed, and only x will be on the stack, and after call G finishes, the result of G of 2 comma y comma minus z will be on the stack. Okay, if this is the C code, x plus G of 2 comma y comma minus z star phi, then this is how this will be: push x, push 2, push y, push z, negate, it will become minus z, then call G, then the answer for that will be available. Now I say push 5 and do star. So whatever the result of this G2 comma y comma minus z gets multiplied with 5, and that answer will be on the top. Now I do plus, that gets into x plus this. So this is how we actually start generating code for expressions. So whatever I have described here is we want an infix. So this is how the code writing we need to do. If the expression is a number n, we need to push n. If the expression is a variable, push that variable, whatever, whether it's a field or static or local or variable. If the expression is of the form exp1 op exp2, first you finish writing the code for exp1, then for exp2 and output op. So this basically takes care of your postfix notation. And if the expression is of the form op exp, then actually code write exp and then output op. Okay. So this will, so code write exp will make the answer of that expression on the top of the stack, and if I say op, that whatever unary operation will happen on the top. If exp is function of exp1 to exp2 to etc., we will write code write of exp1, we will do code write of exp2, and then at the output we just say call f, right. So what we essentially mean is that push all the arguments of the function f and then do a call f. Okay. So this is how we start writing code, and the most important thing that we need to keep up here is about this, which will take care of your postfix notation. And why do we need postfix notation? Because then only I can implement it directly on the stack. So when I am writing a code for expression evaluation, that should, since the VM is a stack based virtual machine, everything would be mapped onto the stack. So x is equal to a plus b minus c, this was the source, and this is the XML code you wanted, and from this XML code we need to get this particular pseudocode. Okay, so this is so what happened in project 10 was this x is equal to a plus b plus c got converted to this, and in the case of this current project, we need to parse this XML code and get this VM code. And in many languages, lot of time we are given this operator priority. Suppose I say a plus b into c, b and c are multiplied first and then a, right. But in the case of our Jack language, we give a left to right priority. So the Jack language definition specifies that expression in parentheses are evaluated first, however, right. So the main thing is that, so when we are trying to do this, when I say a plus b into c, we will be doing a plus b followed the whole thing into c. That is what we mean by left to right priority. But suppose I want to do a plus b into c, then put b into c in a bracket, and that will be useful for us, right. If you do not put it in the bracket, then it will be treated as a plus b into c. If I want a plus b into c, then put b into c in the bracket. Okay. So this is all about handling expressions, and when we actually construct the compiler, we will get lot more insight of how do we go about handling the VM code for expressions, right. Now we will, in the next module, we will start looking at handling the flow of control. Thank you.